All right, today we're diving headfirst into one of the biggest questions you can possibly ask. We're opening up the case file on reality itself. The big question, is any of this real? Or are we all just characters in an unbelievably advanced video game? Let's follow the clues together.
So our first piece of evidence, it comes from the worlds we've created ourselves. Think about this. In just about 40 years, one lifetime, we went from playing Pong, with its two little rectangles and a dot, to creating virtual worlds that are getting scary close to the real thing. Now, if you just assume that progress continues, at any rate at all, it feels almost inevitable that one day, a civilization, maybe us, maybe someone else, is going to build entire simulated universes. And that, right there, is where the odds start to get really, really weird.
You know, it's this rapid technological leap that led someone like Elon Musk to a pretty staggering conclusion. He claims the odds that we are living in the original base reality are 1 in billions. And that's not just a hunch, it's actually based on some pretty cold, hard logic.
And this brings us to our first major clue on the detective board, an argument that doesn't rely on physics or technology, but on pure, simple logic that kind of forces us into a very strange corner. The whole foundation for this modern idea was really laid out back in 2003 by an Oxford philosopher named Nick Bostrom. Now, he didn't just come out and say, hey, we're in a simulation. No, he did something much cleverer. He gave us a powerful thought experiment, basically a puzzle, arguing that one of 3 very specific things has to be true.
So here's how his trilemma works. Option 1. Almost all civilizations like ours go extinct before they get smart enough to run these ancestor simulations. Option 2, they get smart enough, but for whatever reason they have absolutely zero interest in running them. Or option 3, we are almost certainly living inside a computer simulation. So think about it. If you believe options 1 and 2 are pretty unlikely, well, then basic statistics just takes over. For every one real base reality, there could be thousands, millions, even billions of simulated realities. And if that's the case, the odds are absolutely overwhelming that we're in one of the many fakes, not the one and only original.
Okay, so the statistical case is our first pin on the board. Now let's run a red string over to our next clue, which comes from the world of physics. Because, if our universe is a simulation, it would need to run on some kind of computer, and that computer would have to be designed to be efficient.
Just think about any video game you've ever played. The console or PC isn't rendering the entire world in full, glorious detail all at once. That would be an insane waste of processing power. No way! Instead, it uses a smart trick called lazy evaluation. It only renders or draws the stuff that you, the player, are actually looking at.
And here is where things get absolutely wild. The bizarre, mind-bending world of quantum physics seems to work on the exact same principle. It's as if our universe is trying to save on processing power by only rendering reality when somebody is actually there to look at it.
The perfect example of this is the famous double-slit experiment. When you're not looking, a tiny particle like an electron just exists as a wave of possibilities. It could be anywhere and everywhere at once. But the instant you measure it, the instant you look, it snaps into a single, definite spot. It's like the universe said, oh, you're looking now? Okay, here, I'll draw the particle for you. But it gets even crazier. Something called the delayed choice experiment shows that if you observe a particle after it's already gone through the slits, it will retroactively change its own past history to make sense with your observation. Think about that for a second. The system is literally rewriting old data to keep the simulation consistent.
So the universe itself might just be a giant, efficient render engine. Okay, but what about us, the people doing the observing? Well, our next clue suggests that what we think of as reality isn't the real world at all, but more like a custom-built user interface.
This is where cognitive scientist Donald Hoffman comes in with a really compelling idea. He argues that evolution didn't shape us to see objective reality as it truly is. Instead, it gave us a simplified headset, a user interface designed for one thing and one thing only: survival.
According to Hoffman, trying to see the actual truth of reality, all the complex code, the overwhelming data, would be completely useless for staying alive. So instead, evolution gave us a nice, clean desktop with helpful little icons. You don't need to understand the complex biology and physics of a predator. You just need to see a snake icon that your brain translates as danger, run away. Our reality is built to keep us alive, not to show us the source code.
Now, if our reality is a simulation, every single bit of data would count. To save on storage, it would have to have some kind of powerful data compression algorithm running in the background.
And believe it or not, in 2022, a physicist proposed a new law of physics that looks exactly like that.
So this physicist, Melvin Vopson, proposed something called the second law of infodynamics. Now, we've all heard that in physics, things tend to get more disordered and chaotic over time. That's entropy. But what Vopson found is that information entropy, basically the amount of raw data in a system, does the exact opposite. It's always consistently decreasing over time. It's almost as if the universe is constantly running a program like WinZip, trying to compress itself and delete any redundant data to save space.
And this is not just some abstract idea. Vopson found evidence for this data compression absolutely everywhere. Viruses, like SARS-CoV-2, don't just mutate randomly. They actually mutate in ways that reduce their own information content, making themselves more efficient. The way electrons arrange themselves in atoms follows rules that lead to the lowest possible information state. Even nature's love of symmetry is a form of data compression, because a symmetrical object just takes less information to describe. This pattern is woven into the very fabric of our reality.
So the circumstantial evidence is really starting to pile up, isn't it? But, every good detective knows you have to seriously look at the evidence that doesn't fit the theory. If we're really living inside a giant computer program, where's the hard proof? Where are the bugs? Where are the glitches in the matrix? And this, right here, is where the case hits a pretty big wall. Major, expensive experiments have been run specifically to look for these glitches. The Fermilab holometer was designed to see if space-time is pixelated, like a computer screen. Other studies have looked at cosmic rays, searching for patterns that might reveal an underlying grid. And the result in every single case? Nothing. Zip. Nada. As far as our best instruments can tell, the universe is perfectly smooth, with no sign of a digital structure underneath.
The theory also has this huge philosophical problem called infinite regress. I mean, okay, let's say we're in a simulation run by some super advanced civilization. Well, who's to say they aren't in a simulation run by someone even more advanced? And on it goes. You get this endless chain of simulations, turtles all the way down, with no original base reality anywhere to be found.
Now, to be fair, there are plenty of anecdotal claims out there. You'll hear about some pretty fringe experiments where people claim to have seen what looks like source code written into the fabric of reality. But these are just stories, not controlled, repeatable scientific experiments. So for now, they have to stay in the file labeled fascinating but not evidence. Okay, let's step back and look at our whole detective board. We've got strings connecting clues from pure logic, from the depths of quantum physics, from cognitive science, and even from brand new information theory. And they all seem to be pointing in the same very, very strange direction. So after weighing all of that evidence from all these different fields, the big question is still just hanging there. It feels like science fiction, but it's a conclusion that the clues just keep nudging us toward.
And the final verdict? Well, the case is very much still open. The circumstantial evidence is incredibly compelling. There's no doubt about that. But without that one definitive piece of hard evidence, a repeatable glitch in the code, a confirmed pixel of space-time, it has to stay a hypothesis. A really, really interesting one, but a hypothesis nonetheless.
And that leaves us with one last, really provocative thought. If the evidence keeps building, and one day we do find that proof, maybe the most important question isn't if we're in a simulation. The real mystery, the next great investigation, would be to figure out why.